Hello all. Very good morning, and thank you for joining this week 1 day 2 training awareness program from National Blockchain Network Zanzibar. We have today with us Santosh Thomas and Kevin Thomas, both walking us through that training and awareness of this blockchain, right? In general, and also they will also talk about something on the Zanzibar National Blockchain Network as well, right? So before we will move, right, we want to have a quick introduction, right, so that we know each other, right? You can tell about your name, what do you do, and what is your expectation from this workshop. So David, can you start?
Yeah, morning everyone. Just a quick intro again. My name is David. I'm from Dar es Salaam, Tanzania. I'm a Web3 builder. I am building alongside the lines of DeFi, decentralized finance for saving groups and village groups and communities like SACCOs and the like. Yeah.
Thanks, David. Dodoma, can you take a moment and
My
introduce yourself?
name, good morning everyone.
I think the person having some issues.
Okay, we'll come back to him again. Farsam.
Okay, this is Farson from Zanzibar, Tanzania. Basically, I am founder of Farson Company Limited. We are a tech company. We are dealing with blockchain technology, Web3s, cryptocurrency advisory, investment advisory. Yes, something like that. Thank you.
Okay, thank you. Yusuf, can you introduce yourself?
Yeah, my name is Yusuf. I'm from Tanzania, Zanzibar. There, we're just dealing with blockchain opportunities and everything inside the blockchain network.
Okay, thank you. ASM. Okay, fine, no problem. We will not waste our time. So I will ask Santosh and Tivin to start with this session. Over to you guys.
Yeah. Thank you, Vinay. Yeah. So good morning, good afternoon, everyone. Yeah, thank you for joining today. Yeah, myself, Chibin Thomas. I'm working as a senior blockchain developer in Jet5. So today we are going to I'm going to take a brief introduction, or we can get some idea regarding um, the need of cryptography in blockchain. Okay. So I think in the last class, last session, we had some introduction to the blockchain. Actually, my colleague Santosh already taken some deep introduction into blockchain technology and its things. So I think you are remembering the details regarding the blockchain. So a blockchain is actually, we can say a blockchain is a decentralized ledger, or we can say it's a distributed decentralized ledger, or in other ways we can say it's a distributed database shared among multiple computers. Okay, and it's mainly we can say blockchain is mainly used for ensure secure transaction, and in order for doing such type of transactions, many cryptographic methods are we are using. And I will come to the cryptographic method. So mainly those things are used to protect data integrity as well as data security purpose. So because of these type of cryptographic functions, the blockchain can easily eliminate intermediaries while maintaining the trust as well as transparency. So yeah, so we can say blockchain can be considered as a cryptography can be considered as a backbone of our blockchain, because it is mainly providing security foundation for ensuring for ensure trust as well as confidentiality. As well as we can say actually we can say when we come into the blockchain, one of the main advantages we got is we can connect people which are untrusted, or we can say we can connect untrusted parties. So actually this type of communication is possible only with the help of the functions in cryptography. So most importantly, we can say we can create data integrity by preventing unauthorized changes to the blockchain. So mainly it's data integrity, or we can say tamper proof is coming into the blockchain with the help of the functions in the cryptography. Okay, so now we can look into the cryptography basic. So we can say cryptography is the word meaning is hidden writing. So the word cryptography is actually taken from some Greek word crypto and graphy actually. So the meaning is actually hidden writing. So it's mainly we can say the cryptography is a science for securing data by converting the data into some unreadable format, or we can say only the third persons cannot able to interpret what the data is actually transmitting. And cryptography is mainly relying on different things like encryption, keys, and algorithms, and all those things are actually required for protecting data, or we can providing data confidentiality, authenticity, as well as integration. So now, why cryptography is so crucial for our blockchain? Because mainly it provides confidentiality, authentication, as well as integrity. So we can say cryptography is actually playing an important role in ensuring the security of information in the digital systems. First, we can say about the confidentiality. So confidentiality implies only the we are protecting the data, or we are transforming the data such that or any unauthorized person or any third persons cannot able to read the data. So that means only the authorized person with some keys can able to access the information. So that is actually confidential. Next comes the authentication. So authentication means suppose a receiver received some data. So we need to verify from which origin it is coming, whether it is coming from a legitimate origin or a non-legitimate origin. So cryptography is actually enabling some mechanisms like authentication, so which can be used for verifying the origin of the data, as well as mainly we are using some mechanisms like digital certificate or digital signature, such type of things. We are actually passed with the data, and with that we can the receiver can ensure that the data is coming from a legitimate origin. Okay, and the last one is actually integrity. So integrity is one of the main thing we are saying about the blockchain, or we can say one another word is tamper proof. So integrity with the different functions of cryptography, we can able to check like whether the data is modified in between the transmission from sender to the receiver. So for that we are using many functions like hash functions, and with the help of slash functions we can even identify any slight modification to the data. So that way we can say cryptography is a crucial one in the case of blockchain for maintaining trust as well as security in blockchain. Okay, now we need to look into some of the fundamental or some of the terms we need to we are always come in cryptography. So first one is plain text, next one is ciphertext, then key, encryption, decryption, and one more thing is algorithm. Okay, that's part of actually encryption and decryption. So let's start from plain text. So plain text is actually, suppose a sender want to send a message. So that message is actually the plain message. Let's consider hi, good morning. So that itself is called as the plain text. Okay, or we can say it is actually the data that we want to secure. Okay, next comes the ciphertext. So what will be the ciphertext? So the thing is, while we transmitting, we need to secure the data. So for that, we are converting the plain text into some other format. We can say it is an encrypted format. Okay, which cannot be read without any key or some other without knowing the algorithm. So we can say it's plain text will be converted into a format which can only be read by key and an algorithm. So that is actually called as ciphertext. So an encrypted version of plain text that is called as the ciphertext. Next comes the key. So one of the important part of cryptography or all the functionalities in cryptography is this particular thing, key. So all the information which we want to secure from a third party or from an unauthorized user, we need to encrypt or we need to secure it with a piece of information. So that is known as actually the key. So keys are different type. We will see there are some keys are non-shareable keys are there. Some keys are shared between the receiver and sender are there. So such type of things are there. We will look into that. So we can say with the help of key, we are actually creating the plain text as well as from the plain text to ciphertext, as well as in order to produce back ciphertext to plain text, we require the key. So next is actually the encryption, decryption, or we can say the algorithm. So with a particular key and with a message, we cannot create any ciphertext. So we need to use those two things, and we have to create some. We can say an algorithm, or we can say some mathematical formulas are there. So that mathematical procedure actually required for converting the plain text into a ciphertext using the key. Okay, so encryption, decryption are actually a mathematical procedure for ensuring the process of security. Okay, so with the help of key and encryption, decryption, we can generate the ciphertext, as well as with this the key and the decryption algorithm, we can produce the ciphertext back to the plain text. So just I will show a very ancient method of encryption. So this is actually used by Julius Caesar in his period in that century, mainly for some military communication. So in that we can see here you can see there is a plain text hello. Okay, so what the ciphertext is Caesar cipher is doing is it will substitute each letter with another letter. So that was a very simple cryptography or an encryption method. Okay, it's just called this comes under the category substitution. So here you can see the plain text given is hello, and the key is actually 3. So it indicates each letter in the from the plain text will be replaced by the third subsequent letter. So if you are seeing H, it is replaced by HIJK. So it is comes as K. And if you see E, you can see EFGH. So it is actually H. And that's the same way each letter is replaced by its third letter down the position. So L is replaced by O and O is replaced by R. So that is actually the key is 3 and plain text is hello, and my encryption algorithm is substitution. Okay, I am substituting with the third letter from that particular letter. So key can be any one, not only 3, it can be 5, it can be 10, any number can be used. So Z will be replaced by, if it is 3, Z will be replaced by ABC. So the third, we will take as a cyclic manner. So that way, we can say this is a encryption technique. So only if the person knows the key, that is, we are using the third letter from the current letter as the replacement letter. So only the person who knows the key is 3, he can revert back the ciphertext into the plain text. Okay, so from the K he will go to H, then from H he will go to E and O to L and R to O. So this is actually from the plain text. With the help of key we are producing ciphertext, and that process is called as encryption. And with the help of ciphertext and the key we are producing back the plain text, and that is called as decryption. Okay, so any doubt up to this? If any doubt we can clarify.
So guys, if you have any question, any queries, you can raise your hand. We'll give you an opportunity to ask that question now, or anyway at the end of this training. Before that, you will get 10 to 15 minutes for question and answer session. So feel free to participate in this training, right? It should be more interactive in nature, right? Okay, Trivin, you can go ahead.
So now we are going to two categories of encryption. So first one, it is called as symmetric encryption, and second one is asymmetric encryption. So symmetric encryption, in one line we can say it is like using only one key for both encryption and decryption. And in the case of asymmetric, we are using two keys, public and private key. So first we can start with symmetric. Okay, so when considering the both categories, symmetric and asymmetric, it is the symmetric is actually the oldest form of encryption, but still we are using it. But when comparing, it is the oldest form compared to asymmetric. So for encryption and decryption, the difference from asymmetric is here we are using only a single key. Okay, so for both encryption and decryption. So this means that same secret key must be known as well as used by both sender and receiver for securing and as well as accessing the data. Okay, sorry. Okay, so it is very simple. We can use a single key, and for doing encryption, like what we see in the Caesar cipher, it is using 3 for encryption, and decryption person also using 3 as the key. But one of the main challenge in the symmetric encryption is how to share the key. So in order, before communication itself, both the parties, that is receiver and sender, need to be communicate the key. What should be the key they are using for encryption and decryption. But there are different advantages, like when comparing to asymmetric, the symmetric algorithms are very faster in execution, and we can say it is efficient while even though the data is very large. Suppose you want to encrypt a file or a database, some values. So all those things, or in a communication streaming. So for all those purpose, we can use still it is using the symmetric procedure. So some way, maybe with the help of asymmetric, we are communicating the secret key, and then we are actually starting the asymmetric encryption and decryption. So some of the algorithms, mainly we are main common algorithms are AES as well as DES. Okay, so here we can see a diagram representing the symmetric key. So here you can see this is the original text, or we can say the plain text. So we will apply the encryption algorithm with the input as the plain text as well as the symmetric key, and we are producing the ciphertext. Okay, so from the ciphertext, we can say in order to produce the original text, we have to use this same symmetric key. So receiver must be known about the symmetric key. Then only he can apply the decryption procedure, and he can revert back the ciphertext into the original text. Okay. So next comes the asymmetric cryptography features. So in the case of asymmetric cryptography, we can say when comparing to symmetric, in asymmetric we have two keys. One is public key and the other one is private key. And because of that, this asymmetric cryptography is also known as public key cryptography. So it is actually, we can compare it to the asymmetric cryptography. We can say it is a modern encryption technique which create two keys with some mathematical procedure. So both the keys are having some relation, but one complex thing is that we cannot find the private key from the public key. Okay, so here the thing will be public key is actually shared globally, or we can say we don't need to keep the public key secret. But when if you think about the symmetric key, we are saying the key that should be shared only with the sender and receiver, not anyone. So if anyone is getting the key, shared key, then it is compromised. But when come to asymmetric key encryption or public key encryption technique, the public key is actually an open key. That means globally we can show this is my public key. Okay, and private key is actually kept by its owner. So with the help of those two things, we can produce the secret communication. And there here we don't need to say about the challenge of how we share the key, because the public key we can list everywhere. Okay, this is my public key. Okay, now we can see the diagram how we can how we are doing the secure communication with the public key and private key. So if you look into the diagram, there are two things, the public key as well as the private key. So every person who want to send some message to another person or the recipient, okay, so the recipient is maybe already having the public key, public key of the sender. Sorry, suppose a sender want to send a message to the recipient. Okay, so what we need is we need to pass the message in a confidential manner. So one line I forgot. The thing is, we are encrypting the message with the public key. Okay, so if we encrypt a content or if we encrypt the plain text with the public key and produce a cipher data, then only with the corresponding private key, I told you we are mathematically generating a private key and a public key, so they have a relation. So with the same private key, that is which is related to the public key, only with that private key we will be able to decrypt the ciphertext back to the plain text. Okay, so a sender who want to send some message to a recipient, firstly he have to get the public key of the recipient. Okay, I want to send message from sender to recipient, so he have to take the public key of the recipient, then encrypt the plain text with the public key and produce the cipher data. So now we can say this is a confidential data, because only this person who is having the private key, can only able to decrypt the cipher data. Okay, so only the recipient who is having the private key can able to decrypt the data. So we can say we achieve confidentiality in passing the data. So some of the mainly we are using in HTTPS as well as email encryption, or we can say in blockchain transaction or communication between different nodes to node communication. All those things we can say we can use this type of asymmetric encryption. So mainly used algorithm. One of the algorithm is RSA algorithm. Okay, so here you can see public key is used for encrypting and private key is used for decrypting. So one more method is there, that is this asymmetric encryption. With help of private key and public key, we can achieve one more thing, that is authentication. So I already discussed what is actually authentication. So authentication means only the person, the receiver needs a sender is sending a message to the recipient. Okay. So what the sender is doing is he's actually encrypting the content with the private key. So that is also there. If we encrypt the content with a private key, it can be decrypted using the public key. Okay, so previous diagram we saw the opposite thing, generating the cipher using public key, decrypt using private key. But here you can see encrypting using the private key and decrypting using the public key. Okay, so if successfully the recipient, so public key everyone know the public key of the sender. Okay, so if the recipient is able to decrypt the decrypt the ciphertext successfully, then it means it is encrypted with the corresponding private key. So, but the private key is secret, only knows with the sender. So we can confirm that the messages come from that legitimate sender. So we can achieve authentication here. Okay. So we can say in blockchain mainly we are using this type of encryption and decryption method for securing the transaction data as well as for ensuring privacy. Digital signature is mainly used for transaction, also making the things tamper proof. And also for node to node communication, we can make it as encrypted. And we can say it safeguard the data exchange between the blockchain nodes, or we can say blockchain participants. And last, we can say we all are using wallets in the blockchain. So that there also we are seeing this concept private key and public key. So next comes to another technique in cryptography called hashing. So one of the mostly used technique in blockchain mainly for data integrity. So what is actually data integrity? Okay, so data integrity means consistency of the data, or we can say reliability of the data in the entire life cycle from sender to receiver, or in the entire life cycle, storage from retrieving storing the data. So we want to ensure that the data is not changed while transferring from sender to receiver. So that is actually reliability, or we can say data integrity. So one of the function of cryptography is called as hashing. So hashing is mainly used for achieving this data integrity. So we can say data integrity is a one-way process. That means in the encryption decryption, it is a two-way process. If we encrypt, we produce a ciphertext, and ciphertext can be reversed to plain text. But in the case of hashing, there is no reverse. We can hash a particular data and produce a fixed value of fixed size in hashed data, but there is no reverse. We cannot convert a hash data back to its original form. Okay, so and we need to say there is a unique hash. That means each piece of data generate a unique hash. If even there is a small change in the data, the output will be different. Okay, so a hello, if we pass hello, it may generate some data, maybe a 16 character data or a 32 character data. If you change HELLO into HELO, then in the hashed output, in the 16 character, there may be a lot of changes. So even a single letter change in the data can produce lot of change in the output. Okay, so always there will be a unique hash. As one more important thing is, next is collision resistant. That means no duplicate hash. That means no two different data produce the same hash value. If you input hello, if you input hi, it will produce only two unique hashes. Okay, so when coming to the blockchain, this is actually one of the important thing. So here you can see a diagram. We are using inputting the plain text, and we are applying the hash function, and it is producing some hashed text. But there is no reverse. We cannot able to produce anything back. And hashing algorithm, some hashing algorithm having the key, but some hashing algorithm does not require any key. It will just produce a chunk of data. So if your length of the plain text is any number, but the output will be a fixed number. So 16 characters output for any plain text data, any length plain text set, always the output will be a 16 character data. Okay, if you configure like the hash is 32 character length, then if for any plain text length, it will be a 32 character length. So mainly in the blockchain, we are using this hashing for linking the blocks. Okay, so we know that why it is called as blockchain. So all the data are actually linked. So in blockchain, hashing links blocks using some, we can say, hash pointer, or we are that way we are actually creating the blockchain, or we can say a secure chain we are creating. So with this, we can actually verify the authenticity of a transaction. Like if suppose if we want to change some data in a link or in a chain, we have to modify from the beginning. Okay, as well as that's why we are saying the blockchain is immutable. So without hashing, we cannot say blockchain core principles like security and trust are not possible. Okay, so mainly we are using this hashing technique. Okay, so I'm concluding the session. So we gone through. We found that cryptography is a fundamental thing for the blockchain technology. Mainly, we can say it ensures security, privacy, as well as trust in decentralized system for protecting data, as well as verifying the authenticity. And we gone through hashing technique, encryption technique. There are much more advanced technique are there, like digital signature and all those things are there. And yeah, together with all these things, we can which act as a backbone of the blockchain. Yeah, thank you.
Yeah. Thank you,
Thank
Stephen.
you, Tipin.
Santosh, you want to walk through
Oh.
on some of the examples or something that you want to for our blockchain network also?
Yep. I would like to just discuss on how some implementations can be done.
Mhm.
Just usually mainly when in most of the applications which we handle, for example, like we have applications like ledger mail and ledger chat,
Yeah,
uh,
basically Mjumbe you are talking about, right? Yes,
mjumbe this
yes.
this this particular mjumbe, uh, what how exactly we are implementing this is using this asymmetric uh,
Algorithm.
encryption decryption algorithm.
Yeah.
So here, when the users actually registers into this mjumbe platform, we create a key pair for the users where the public private keys will be created, and every transaction and every receiver, every user will be having the key pair. So when a sender send any message to the receiver on the other side, it will be first encrypted using this AES-256 asymmetric encryption. It will be encrypted using the public key of the receiver, and it will be transferred to the receiver. And once the receiver receives it, it will be decrypted using that receiver's private key. So this is a pattern which will be followed for every sort of messages, even the if it is a attachment, a files transfer, um, all communication, this is a pattern which is done. So Mjumbe is in Zanzibar blockchain, and in the EDUA, all the things, we are implementing this cryptographic pattern.
You're right. So if the audience, just for the enlightenment of audience, like the this year we have also launched that Mjumbe Waidua, which is a messenger and even that email system, right, which is completely on more secured way, like what Santosh had just mentioned, that is having every message, mail, attachments, any type of files, video, audio, document, PDF, images, whatever we are sending, right? That is getting encrypted, right, with that public key of the receiver, so that only he will be able to open it, right? And that way, that entire communication remains very trustworthy and secured. Even the government to government, the communication, right? That is on the Mjumbe Waidiwa. We are also going opening that with like a citizen to government, which yet to launch that. But yes, government to government, that is what is happening. The similar things will happen with the like a citizen to government. So that is one of the use case which we have done. You can think about the other use cases where you want to have that more secured way of document sharing and all, right? Or any identity, digital identity that you want to secure, those things can be done. There are different countries who has done with the different use cases and all, right? So that is something can we think about, right? And if you have any use case, you can discuss with us. We can also look into that, what can be done in that case, right? Santosh, you have anything on the our NBN side also?
Yeah. I have a question.
Yeah,
Regarding
David.
identity. Because obviously we are working around these marginalized communities, and we've been exploring on best ways to like identify them rather than having addresses. Right. We started building on. We've been exploring like other chains like Near. They have Near names, Base. They have Base names. But we're building on like Ethereum virtual machine, like compatible EVM compatible chain, which is Celo. They don't have like Celo names or nothing. So we've been exploring around ENS mostly. But it would be interesting to explore how we could like provide digital identities and like KYCs for these savings groups, because at the moment they also work with like banks and microfinance institutions. So there's gonna be some KYCs and AMLs there. So I just wanted to like pick your brains there, but I think we can chat more some when it's actually time.
Yes, sure, sure. So, are you looking for that kind of solution to build, or you have something that you want to try it out?
Yeah, so at the moment we still have like addresses and like multi-sig addresses there for safe, but like it would be nice to explore a solution there around digital KYCs and anti-money laundering. So that's an area we still struggling with.
Okay, okay, yeah, fine. We can have that like a more detailed discussion around that along with Santosh and Tibin. We can see that uh, how we can at least we can do some POC on that side.
Yeah. So, Vinay, just to add to the previous conversation which we were having on the Zanzibar National Blockchain Network, we have some plans like, let me share my screen. Um, 1 minute. So, yeah, this is the way of Zanzibar National Blockchain Network, which is going to be implemented. The sandbox is ready now, and the first thing what we are going to do is digital document verifications. So in this case of digital document verifications, also we'll be using this sort of cryptographic thing, and this is one step we'll be implementing initially on the Zanzibar blockchain network, where this application here, every document generated by this government authority will be digitally verified over the blockchain using this cryptographic hashes and signatures. And once when a document is presented to this government, it will be cross verified, and even it will be any third party can avail this service on this Zanzibar blockchain network to verify any sort of documents which they have received. So that is here, that is what we are there looking forward in our roadmap. And this e-governance also will be happening over the blockchain, and everything what we've discussed is based on this cryptography. Thank you, Vinay. Over to you.
Yeah.
Okay.
Another quick question: are there like other use cases that you guys have been exploring with like the government of Zanzibar, in other fields? Let's say, because I heard there was a time Tanzania was exploring. I think it was tax and Tanzania Revenue Authority to exploring like blockchain solutions. I was asking if there's other use cases other than digital identities that you guys have been exploring, like.
So other than that, there are two things which is going to be on that NVN only. One is I told you we were discussing about Mjumbe. So Mjumbe, both for messaging and the mail, is completely going to be on the NVN. The another one is that eDua, which is a unified digital government platform, right, where that all the government services will be available for all the citizen, residents, tourists, and all. Right. So that entire thing, right, will be also backbone by the NBN, right? So that is like a very big ambitious things that is going to happen, and it's happening right now. So yeah, apart from that, there are different services which we are able to find out based upon the different MDAs and government. We are building it. One of them is like what Santosh has mentioned, digital document services, right?
Yeah, Asam, you had raised your hand. Anything from your side?
Yes, definitely. That is what ASM we are trying to do, right? With this all awareness and things, right? We are looking at how we can get the locals, right? Right, partners and the startup or developers who are looking for some kind of use case to do that, right? That the whole objective of this awareness, and even if you look at in case of NBN, right, how if you'll go to their website, how you can collaborate and all, right, we are opening up that. We are creating some like a procedure for that, like how they can come up and they can start doing that. We are working on that direction only, right? Such college like Karume College company, such someone I heard he's from Arsham. Since blockchain issues seem such fraudulent or scam missions. I'm not very clear with your question. If you can unmute and talk, probably that will be better or if anyone can elaborate if they understood this. Okay, fine. I got your point. So yes, that's a thing. Like usually when we say blockchain, people think about cryptos. So yeah, crypto is one of the use case, right? But here, if you look at, yeah, I got your point. Yeah, so that's the reason we are trying to create this awareness. Like we are looking for here a different use case which can come into the blockchain and provide more transparency, security, and different kind of features which blockchain as a technology provides, right? So yes, thank you. Thanks for bringing this. Any other question? I'm not aware of Farsham company, but yes, it's possible. What are the use cases? Okay.
So, yeah, Vinay, I can show the NBN that sandbox. Just give me a minute. I will.
Okay. Okay. And yes, I saw that. What are the use cases for blockchain technology in insurance company? Okay. See, I will tell you for each kind of like a domain, right? When we are finding that uh, the trust is an issue, the fraud is kind of things that can be possible there, right? Anything that can be manipulated, there could be like a conflict, right? If we are going to introduce blockchain, which is going to make it as more seamless in that case, right? So if you'll ask me for the insurance, yes, like uh, for KYC, AML, that kind of things, right? There could be like a claims handling, how it is going to happen, right? You can We can look into that in deep dive, maybe in subsequent one of the training where we can take this huge case also, right? And we can talk about like how and what are the different things can be handled with the blockchain much easier way, right? So something which will, if you look at blockchain, right, which will create something like a immutable trustworthy record, right, of any product, right? For, track product ownership, like who is owning that, like somebody has taken that insurance, what is the claim that they are going to get in the real time, right? There could be multiple things which can be done in that case, right? We can talk about in more detail around that particular use case in upcoming session, right? We are trying to start with the basics of blockchain, which the first session we have just touched upon, that what is the why, what is blockchain and what are the features, right? Just as a layman, if we should be able to understand this particular workshop, we have just tried to go little deep dive on some of the features which is making unique for the blockchain, like hash, right? How the blockchain transactions are immutable, why we are saying that this is like a, that much secure, right? So that we have touched based upon the cryptography and the hash things, right? Similarly, we are going to add more detail on that side and with the domain also. So you will hear on that those things. Yeah, Santosh, please, you can share and you can do that in quick because we do not have enough time now, only 3 minutes.
Yeah. So can you see my screen now?
Yes.
Yeah. So this is the blockchain sandbox right now. So this, the one which we are seeing right now is the blocks which are getting mined, and this is a subnet, and here we will be syncing these things with the parent, that means with the parent chain we'll be checkpointing this one. So this is the way how it is happening. This is only one of the control panels which I'm showing you. um, Here the speciality of our this blockchain is that even though it is a public blockchain, this is actually governed by the Zanzibar blockchain, National Blockchain Authority. So uh, to get an access to this one, even it is not a private blockchain, it is a public blockchain only, but to get an access to this particular blockchain, you will have to register, and then we'll be giving an access to this one, and you'll be getting the required tokens, so that you can proceed with your transactions and all. So whenever you submit your use cases, like it will be gone through and you will be given the access. This is mainly to make sure that this blockchain doesn't get misused, and the applications hosted on this blockchain are really authentic and trustworthy. So that's why there is a access scrutiny happening for the Zanzibar blockchain network, NBM.
Yeah, so if you have submitted your registration, like I know David has done already, and we are in the working on to giving him that access and all. What you can do is you can go to that NBN dot Africa. There you will get a section for how you want to collaborate with us, and on that side, right, you have to fill a form, what use case you want to do and all, and then you can be able to we will set up a call and discuss with your use case, and yes, of course, after that we'll start working on to give you access and other things. Let me just share my screen, right, just for you guys if you are not aware of this. So this is what the NBN Africa, right? If you want to apply, get involved and apply. If you click on this, it will open a Google form and you have to fill all the details like this, right? And here you have to fill the form, right? What kind of things that you want to build and all, right? What are the support you need? And after that, there will be a meeting with the technical team. And then, yes, of course, that will be finished, right? We will be working with you guys on that line. We are still coming up with the right procedure and all, right, giving that access, and so just wait for some time, you will start getting that. But yes, what I would suggest, like if you can start applying from their side, we will be getting in touch and we will be discussing on those things. Anyway, this awareness going on, we will be also discussing on those use cases which you might be interested and all. And yes, of course, in a week or two you will be start getting that, how you can access, you can build, you can start testing that, right? And we will be providing all our technical support in that case. So our site is https, if you go nbn.africa, right, you will be able to access. And from there, if you want to go to a specific section, right, get involved and apply. And then from there, you can just fill the form, right? I guess we have taken some more time over 2 minutes, right? So any further question, you can please feel free to write to us, nbn@eguys.go.tz, right? I will just put it here. We also have a Telegram group. You can be part of that, right? We can have that some discussion more on that side there also, if it is something relevant to everyone, right? Otherwise, you can just send an email to us on that line, right? So that's all from us for today. Thanks for joining. Thanks for giving your time. I hope that you have got some understanding of the blockchain core features, plus some idea about that NPN network as well. And see you guys again on Friday for this awareness program. And also would be really feeling glad to collaborate with you for your use cases, and definitely will make your use case also successful. Okay. Thank you. Thanks for your time.
Thank you all.
Thank you all.